All right, so this is indicator 8, day 1. We're going to be talking about correlation and nonlinear and linear correlation. And then tomorrow we're going to talk about scatter plots and line of best fit. And that'll be it. Indicator 8's a nice short one. All right, so first is the word correlation. What does that mean? Correlation just means it has a pattern, okay? That they go together in some good pattern or some noticeable pattern. And it's kind of like if you correlate your outfit, right? Your pants match your top, or if you correlate with your friend, then you guys kind of match each other. That's what correlate means. So if you look at these 3 boxes, your options for correlation are going to be positive correlation, negative correlation, or no correlation. Okay? Positive correlation just means it runs uphill. It means you can tell there's a pattern. You can look at it and you can see that all the points are pretty clustered together. They make a good pattern. And in this case, it's positive because it runs uphill. Okay, that's what makes it positive. Cole, do you have a piece of paper? Do you have a piece of paper and a pencil? Okay, if you want to come up here and borrow a pencil and get a piece of paper, we take notes every day when they're up on the board. You save your notes in a 3-ring binder, and then the notes that are worth points. And there you go. Okay? All right. The next one is negative correlation. And again, you can look at the points and you can see there's a pattern. You can see they all kind of tightly stick together in a certain pattern. And in this case, if you follow it, they run downhill, and that's what makes it negative correlation. And then that last box is no correlation. And that just means they're just scattered all over the place. There's no rhyme, reason, pattern. It's kind of like me if I try to play darts. It's a sad, sad thing when I try to play darts. And really, see all the holes? Like if that's the dartboard, there'd be holes all around the chalkboard. I'm terrible at it, but that's fine. So no correlation just means you look at it and you can't see any rhyme or reason or pattern, okay? If the answer is no correlation, the reason I have a box around that is because you're done. That's your answer. You stop there, okay? If it is positive or negative correlation, then we move down to step 2. And I'll scroll down to that in a second. So if when you're answering on your worksheet, it says write whether or not it's positive, negative, or no correlation. If you write no correlation, you square it, box it, you're done, that's your answer. If you write the word positive or negative, then you got to go to step 2 and you got to further decide if it's linear or nonlinear. And I've got a lot of squiggles on here from the last class that I'll take off so it doesn't look quite so over. All right, so if you look at that first line, the first 2 that I'm leaving red next to. All right, the first one is an example of a positive linear correlation. So I looked at the dots. I could see they were running uphill. That told me it was positive. Since it was positive, I had to move to step 2. This is step 2, which is linear versus nonlinear. And in the case on the left, that is an example of a positive linear equation because, right, it's running, you can see here, it's running uphill. And so when it's, there we go. Nope, every time, I want it just a pointer. There we go. I've got a tight-knit group of points. They're positive because they're running uphill, and I determined they're linear because they all tend to be in a straight line. And I can draw a straight line through the center of them and kind of encapsulate them all close to a line. They're not ever all going to sit right on a line, but you can still look at that and see that it's linear. The example on the right is an example of positive nonlinear. It's positive because it is running uphill, right? You can see that it's running uphill, but it doesn't run uphill in a straight line. There is a curve to it. So this one would be positive nonlinear. This bottom left-hand one, you can see that all of them, it's definitely correlation because they're all running together. They're all running downhill, so it would be negative. And they're all running in a pretty straight line, so it would be negative linear. And it's already been done, but when it's when it is linear, either positive or negative, okay, when it is either one of these, either positive or negative linear, you go to step 3. And that is that you draw a line of best fit. And it's already been done there in gray, but I'll redo it in red. So here you would draw a line that runs through all of your points somewhere that makes sense. And you can see that my line of best fit is a little different than the original line of best fit. All of your lines of best fit are going to be a hair different because there's a little bit of opinion in this, right? You might call that the line of best fit. Somebody else might call, let's see, where's a different one it could go? Somebody else might call this the line of best fit, right? I did it in red. You can see all 3 of those would be acceptable lines of best fit. As long as they kind of go through the middle of your points, then it's a good line of best fit. So on the negative linear equation, again, you've got a cluster of points trending downwards. That's why it's negative. They're linear because they all tend to trend in a straight line, and then the line of best fit is drawn there. Now, on the nonlinear side, I don't like these examples, and I get why the person who wrote this out put the lines in there. But if it's nonlinear, you are not going to draw a line of best fit. Okay? So for this one right here, we have to decide, is there correlation? Yes, there is. Is it negative or positive? It's definitely negative, right? Because they're trending downhill. And then you have to ask yourself, is it linear or not? I don't care if with your pencil, if you very lightly do what this person did, which is kind of put the curve in there to really show in your head that there's a curve, which means it's non-linear. But you're not actually going to draw a line of best fit like you are going to if it's linear. Okay? So then that step 3, we've kind of already talked about it. But if it is linear, then you're going to draw a line of best fit, and we'll talk about that here in a minute. But you're going to anchor your line of best fit with 2 points. And that's going to come in handy tomorrow, and we're not going to really go into it today. But tomorrow, when you write equations for your line of best fit, every linear equation needs a slope, and to find a slope, you need what? 2 points. So when you draw your line of best fit, you always anchor it through 2 of your points on your plot or on your scatter plot, okay? So just as a very quick recap, step 1, you ask yourself, is there correlation? If there's no correlation, you're done. You write no correlation and you stop. If there is correlation, you have to identify it as positive or negative. Then you have to move to step 2 and identify it as linear or nonlinear. If it's linear, you go to step 3 and you draw a line of best fit. If it's nonlinear, you leave your answer as positive nonlinear and you do not draw a line of best fit. Make sense? Pretty straightforward. That is literally all there is to day 1. Okay, it's super simple. So we're going to go through some quick examples and we're just going to go around the room. Gwen, is there correlation here or not? Xander, is it positive or negative? It's negative. It's negative because it goes downhill. So our answer is negative. And then Will, is it linear or nonlinear? It's linear. Since it's linear, I'm going to draw a line of best fit. I'm going to anchor it through 2 points. And I want it to go through kind of the heart of my data. So I'm going to go, let's make it red. I'm going to go, that looks good. Now, that's my interpretation of a line of best fit. I anchored it through this point and this point. You might have picked 2 other points. As long as it kind of goes through the middle of your data and it picks up 2 points on each side, I'm good with it. For today's homework, that's all you have to do. Negative, linear, draw a line of best fit. Okay? Tomorrow's video, I'll walk you through actually writing an equation for this line of best fit, but for today, this is all you have to do. Okay? Chase, number 2. Correlation, yes or no? Okay, so that means we go on. Dalton, is it positive or negative? What is it? Positive, good, because it runs uphill. And Houston, is it linear or nonlinear? Okay, if it's nonlinear, whoops, nom. If it's nonlinear, you're done. Okay, you don't have to draw a line of best fit. Now, if you want to take your pencil and lightly sketch it to see that it curves and it helps you visualize it, that's fine. But just do it very lightly so I don't think you're drawing a line of best fit. All right, Bella, correlation or no? You don't have to write all these down, guys. You can put your pencils down and just watch. Sorry, I should have told you that. As long as you have the notes from the first page we did, this is just doing the examples, okay? All right, well, that doesn't mean we're done. That doesn't mean pack up. Just everybody put your pencils down and just wait a second. I shouldn't hear any paper rustling. Thank you. All right, number 4. Isaac, correlation or no? Okay, Kyla, is it positive or negative? Okay, good. All right, Seth, is it linear or nonlinear? Okay, which means I do what? Line of best fit. So I'm going to pick 2 points. I'm going to go through that one, and that looks good. I'm going to put my little arrows on my... And then it's just a good idea. You don't have to, but it's a good idea to kind of blacken in or darken in your 2 anchor points. You'll need that for tomorrow. Okay? All right. Let's see. Number 5, Marcus. Is there correlation? Yes, there definitely is a pattern. Addison, is it positive or negative? Negative, because it runs downhill. Good. And Tyler, is it linear or nonlinear? So I'm done. Okay. Number 6, Ty. Correlation or no? So what's next? That's it. That's my answer. If it's no correlation, you just stop. All right. Number 7, Avery. Is there correlation? Yeah. Okay, good. Cole, is it positive or negative? It's running uphill or downhill? Yep, it's running downhill, so it's negative. And Javen, is it linear or nonlinear? It's definitely linear. And that means we have to draw a line of best fit. That looks good. And I'm going to pick that as an anchor point and that is an anchor point. If there's not an anchor point, and I'll go into this in more detail tomorrow, if you guys notice what I just did, didn't mean to erase my line. Let's put that line back in there. Okay. If I drew my line of best fit and it goes through the heart of all my points, but I don't have 2 points right on an axis, I'm going to put a point. I'm going to put a point right there. It's still on my line. It's still with my other points because I don't want to be trying to find a slope tomorrow using 3.89 as a point. Okay, so make it easy on yourself. And if you and when it comes to this, right, and you're going to name your points, I would name this one 8.2, and I would name this one 4.6. That's going to be close enough. I don't need to know that it's 3.89 and 6.23. Don't do that to yourself. Okay, it'll make it so much harder. I can easily find my slope with the points 4.6 and 8.2, right? So that's just kind of a preview for tomorrow. All right, let's see. Let's keep moving. Where'd I leave off? Logan, is this one correlation or no? Okay, definitely a pattern. Gwen, is it positive or negative? Positive. And Xander, is it linear or nonlinear? Nonlinear. Again, if you're ever not sure, just kind of very, very lightly, just kind of take your pencil and just kind of look and see, oh, it hooks. So we're going to call that nonlinear, and then you can just erase that or make it really light so I know you're not drawing a line of best fit. Okay? All right, Will. I think I'm going to skip that one. Number 10 is obviously no correlation, but I'm going to skip those because I want to show you this. On your homework, you're going to have ones that look like this. And with this, you have to produce your own scatter plot with some given data, and then you have to answer all those questions. So how do you do that? Well, these are XY coordinates, and this is your x-axis and your y-axis. We're used to that. And so we have the point here, 10, 900. Well, 10 is your x-axis, and that is right here on your x-axis. And then 900, you would go up to, now I don't have 900 on my y-axis, but I have 1,000, and 900 is just below 1,000. So you're going to eyeball these. These are not going to be exact. As long as I can see it's right under 1,000, I am not going to get out my ruler and inspect to make sure that you had that exactly at 900. It's just got to make relative sense. Then I've got the point 20, 1,100. So I'm going to go over to the 20 on the x-axis. And then again, I don't have an 1,100, but I have 1,000, and 1,100 is just above 1,000, right? So I'm going to put a point just above 1,000. And then I've got the point 30, 1,200. So I'm going to go over to 30 on the x-axis. And then again, I don't have a 1,200, but I know 1,200 is sort of in between 1,000 and 1,500. So I'm going to put it there in the middle. And then I've got the point 40, 1,900. So go over 40. Again, I don't have a 1,900, but I have a 2,000. So I'm going to go right under the 2,000 line. Let's see, what else? 50, 2,400. So I'm going to go over to 50 and up to not quite to 2,500, right below it. Right here, I've got a 60 and a 3,100. So I go over to 60. I go just above 3,000 because that's where I'm going to call 3,100. And then I have a duplicate point. Do I have to plot it twice? No. Then 73,000. So I go over to 70, which is right here, and then up to 3,000. That's right on a coordinate. That's nice. And then I've got 80, 3,900. So I go over 80, up to 3,900, which is just under 4,000. And then I've got 100, which is right here, 4,400. Well, this line is 4,000. And I know that from looking at my other increments that it goes up by 500 each time. So that makes this one 4,500, right? And I need 4,400. So I'm going to come right below that, and I'm going to put a point right there. Now I've created my own scatter plot. Now I still have to answer all the questions. Is there correlation? Everybody. Is it positive or negative? Is it linear or nonlinear? So I'm going to draw a line of best fit, right? So my line of best fit, I'm going to anchor it into 2 points. Let's do either one of these would work. Okay, and that's why I said you're probably not going to have the exact same answer as your neighbor, but that's okay. So there's my line of best fit. Okay, I've drawn my line of best fit, and I anchored it here, and I anchored it here. Okay, so for your homework, you've got some like the top page we ran through, where you're just going to simply write negative, positive, linear, nonlinear, no correlation, whatever that may be. If it's linear, you're going to draw a line of best fit. Then when you get to the back page, you're going to have to create your own scatter plot by graphing all of these points, then deciding correlation, no correlation, positive, linear, and if it's linear, you're going to draw a line of best fit. That is today's assignment. Tomorrow's assignment, you will have to get on Canvas tomorrow sometime during the day. You will have to watch my video, take some notes in your binder, okay? And then on tomorrow's assignment, you're going to have to do everything you did today, and then the last step is going to be you're going to have to write an equation for your line of best fit. So you're going to have to find the slope and the y-intercept, and I'll talk you through all of that tomorrow in the video, okay? All right, let me stop this recording, and then for those of you at home, go ahead and pull this assignment up on Cami and do day 1, and then tomorrow I will post a video, and you will have day 2 to do as well. All of this is due on Thursday.